Okay, so folks, for the sake of the video, what we are looking at is the exam review for Exam 2 in MEE 120. So we've just started doing an exploded view on the transmission and the transmission case. Okay, so we got these parts pulled out. The next step I'm going to do is I'm going to pull out all the bolts together. So I'm holding down the shift key and I click on that one. Come on. That one. And I'm doing a simultaneous selection.
I think in this case you don't need the shift in this specific case.
Okay. And I forgot one, so I'm going to click in the blue box, add that bolt, make sure all 6 come out together, and I'll say done. Okay, here is where most people fell down. This is where they ripped the poor teeth off my input gear. Almost everybody I've looked at, and I've dinged just about everybody, they tried to do something like this. They tried to pull it out the front. Well, if you notice, that's a little bitty hole, and those are really wide teeth. It doesn't go that way. And this was a trap that I intentionally left for you guys. What I wanted you to do, come on. Why, there we go. What I wanted you to do was go back like that. Oh, stop it. Bring it back like that, say done, then click on it again and go up like that.
That's what had me concerned because I wasn't quite sure about the twisting that you explained, but
Yeah,
because the gear, that piece is just as long as that gap, I figured it'd be all right. Anyway,
yeah, so all we're gonna do is we're gonna create an explode line and we're gonna come out of this bore, we're gonna come back and up to the center of the shaft.
yeah,
And it's okay. Yes, you do have to pitch the front end of this thing down to kind of sweep it through the hole, but that's okay. And then over here,
that was tricky.
this was a little bit tricky. So let's see, we'll choose this piece, this piece, this piece, and this piece. We'll move them
Oh,
all
yeah,
together.
that'd have worked better.
Oh, what's it doing? Try that again.
It barely nearly pulled that square piece out for the slots in the back. That would not have been good.
And then ideally, I would have liked to have seen you. So I'll say done here. Ideally, I would have liked to have seen you go up here and put a trace line down into the saw cuts, those little anti-rotation cuts. Okay, and let's see, the nut should probably go with it. So we'll put that up there and I'll say done. And I'll pull this out and say done. I'll say okay. And let's see how that looks in my named views.
Nice. Try it done.
And, you know, maybe when I get done, I'm going to look at it and say, yeah, maybe something like that. So I can see the trace lines coming into these holes. But I'm looking for something like this, some general kind of sort of like that. If you give me something like this, I'm fine with that too. Okay, so let's put in our explode line sketch. And I intentionally messed with you guys on one other thing. If you look at the little triad down here, okay, we always start drawing on the XY plane, but XY is across the face here. So if I just draw a line and I click on screen points, that's the way it's going. And if I click on a line and go like this,
Yeah,
it's still not going in the XY direction.
that's why I like the automated thing for some basic stuff at least.
Hey, you know, if you can get the automated thing to work and look good, okay, I'm fine with that. I just rarely get it to work well, so I just like to do it by hand. That I know that always works correctly.
Yeah,
All right.
that trap didn't really get me. I think it just because I was always dimensioning from circle to circle, so I could always click on a point.
Yeah, a lot of it was pretty simple. And I really wasn't trying to make a brutally hard test. Let's see, this one goes over here. Maybe if we have a final, I'll make a brutally hard one that challenges everybody.
You felt bad because we screwed up the other exams. That's why.
Yeah. What surprises me is that usually it's the first, or excuse me, this exam that everybody complains about. They say, oh my God, it was so awful.
Actually, I got it done in almost half the time it took the other one. I can say that now that we're done with it.
All right, so let's see. Okay, so those lines actually did go to where I wanted. Yeah, I got to tell you, as I was listening to you guys on the first exam, I thought, oh my God, I'm going to kill these poor people. Like, oh my God. Oh.
I try to ask questions that give a hint without really helping. Obvious, make it obvious that I'm helping.
Yeah, and I was trying to stop you guys from doing that.
But remember the question I made? If you specifically need center lines on the main, the main assembly, that was the reason I asked. Maybe someone.
Yeah, I had a feeling that was the case. I was like, man, maybe I just need to mute this guy. So I'm putting these lines across, not because I need them, but because it's just an easy way to locate in space. And now I'm going to come up. I'll come up vertically. There we go. And I don't really know where the face is, but that's okay because we can use a geometric relation to get there. So I'll add a relation, I'll choose the endpoint and the face, and I'll say on plane, brings it right up to the plane. Then we'll do this one, and we'll go right up to the plane. And let's see, we got to do something about our input shaft. We'll click on the center there. And I'm going to hit the tab key.
Which key?
Tab.
Oh, okay.
Tab swaps your drawing planes.
Okay, that's a good hint.
And then, let's see. I think I'll just come up like that. This is all I'm really looking for. So again, I'll do an on surface. And that's it. Just says I'm coming down and then I go forward into the mating hole. So we'll save this.
So when I took the little square part out, I pulled it up, or pulled the nut out and then pulled the square part up, without pulling it out.
Yeah.
Where you have it, that should be fine too, right?
Yeah, I'm not going to be super fussy about that because this is the first time you've ever seen this geometry. So, it's not fair of me to ask, really geometric specific stuff. So I'm really looking more toward good methods. Most of the stuff I'm dinging people on is, oh, you forgot the material note, or you forgot, something like.
Sorry. Do we need the material note on the assembly?
Correct. No material on the assembly. So, for example, in this case, this housing that I rebuilt last summer, this is cast iron. This is 4340 high-grade steel. I don't recall what this gear is, but it's a different alloy. This thing has 52 100 grade balls in it. You got a whole bunch of different materials in this thing. So it's only fair to call them out at the piece part level. Okay, so then oh, whoops. Not in my explode sketch. We'll click on that. We'll get rid of that. Click there, get rid of that little piece of construction geometry. And that would be pretty much, in my opinion, a 100 on the explode. And the big thing there is I wanted to make sure that your lines were going where you thought they were. They're not going way off in space. And you didn't pass metal through metal. And the way you tell the assembler to assemble the parts just matches reality. So you didn't try plowing this poor gear through the front of the case.
Are you grading our exploded views, or are you just grading what the view on the drawing?
Well, I have been going in and looking at your assembly.
Okay.
So that if I need to tell people, hey, your lines were way off in space, check the plane you were drawing on. I think that's necessary feedback.
I see.
Okay, so we'll make our drawing. Get rid of that. Okay, so we want maximum length, width, and height. I still don't really like this scale. That's looking a little too big. What does 1/8 look like? Yeah, that's a little small. All right, we'll go back to a quarter. So on sheet 1, what I want to see is make sure the isometric has the hidden lines turned off. I want to see maximum length, width, and height. Okay, this case width is actually set at the component level, so this has to be reference, so it's not a double dimension. Same thing with the length. Okay, I told you guys to set the extension of the input shaft at 7 inches. Well, it just so happens to be 7 inches. So I just put a live dimension like that. That's all I wanted. So let's see, I got the width, length, and I need the height. Height is set by the case, so I got to make it reference. Okay, so then you need to make sure we have center marks and center lines.
How badly would you ding someone if they forgot that in the heat of the moment?
Oh, not much, 30, 40 points.
I mentioned them just for this reason.
Really, though. I mean, like, it's not nearly as important as if it's in a piece part.
No, it's not. And it's honestly mostly just a conventions thing.
Okay.
So it's no more than a couple of points. It's when what I see as important is that you don't tell the assembler to do something that can't be done. I really get crazy over dimensioning to a hidden line. That one I hit people harder for. But still, that's a conventions thing. Things that are going to impede you from actually making the part, yeah, that I have to get serious on.
Okay. Because it was about 10 o'clock last night, I realized I forgot the center line.
Oh my God, not that.
And I just realized I forgot an isometric too, but again, not as important on this because you have the second page which shows it in depth, right?
Well, I mean, should be there, but at the end of the day, the isometric is nothing more than a visualization aid. It doesn't impede you from actually making the part. And let's see, center lines. So these are the holes for the cover plate. And
That math, I think. I may be back shortly.
okay.
In which case, thanks.
So that's about all I'm looking for on the first page. Really nothing exciting. Sheet 2, we're going to put in our exploded view and balloon it. Oops. What's going on here? Did I choose the wrong? Drawing view, model. Let's try it from the top. Show in exploded state. Okay, there's the view as I wanted it. Can we go up to a quarter scale?
Yeah, that's what I use.
Yeah, it looks pretty good. And yes, I cannot see these back installation holes.
It would be
Again,
pretty clear to anyone putting this together, though.
yeah, it would. I don't think they'd have any problem getting it. So then balloon. I don't care if you just put one balloon on these 6 bolts, because to me that's painfully obvious that they're all exactly the same and they're just part of a bolt circle.
There is a
Knowing that, I
there
wouldn't
is
say you're in trouble.
Say again, Emmanuel.
there is a button when you put the balloon on the bolts at the left. It says quantity. It will put a 6x right there. Oh,
Okay.
yeah, it's obvious. It's on the left of your screen right now.
Okay, that's nice. Yeah, if you want to use that, I'm all good with that. Okay, and there we go. That's all I expected to see. Well, we got to clean up the title block, however. So let's see, what is the scale? We used quarter scale. And that's it. You give me some very close variation to that and I'm all happy. I did notice a few people were putting their parts right over each other. I personally would rather see a little bit of white space around each part rather than overlapping them. Again, it's not a hard and fast rule, but it is kind of a taste thing.
Yeah, I had a little trouble making sure the nuts were clear enough by themselves. But I think I got it all right after 4 attempts. I have 4 or 5 exploded views in my assembly. I mean, not exploded views, new named views of 1 explosion.
I mean, okay. You know, if you went back and you decided you want to try a different view, that's all good. So then let's see, we got to put in our bill of materials now. So insert, tables, bill of materials, get our data from right here. We'll say okay. Sheet 3. And we'll come in, we'll clean up the title block. So scale, I always put NA, not applicable, because there's no graphics in that window. And it's going to be sheet 3 of 3. And a couple people had issues with the idea that there was nothing in the vendor or vendor part number. Well, I can tell you that Ford made their own transmission housings, so there was no vendor. It was made in-house. Same thing with the input shaft and the reverse gear, or the reverse shaft. Ford made all of those, and that's why all of this stuff is empty.
Didn't they make almost everything?
Oh
in-house?
man. So Henry Ford was an interesting character. He believed in completely vertical integration. He said, if I'm building a car, I want to own all the industries that supply all the parts to make that car. He bought rubber plantations, he bought copper mines, he bought steel mills. Yeah,
What changed? It's not the case today. That's the case only with Tesla today.
I mean, I personally do not understand why you wouldn't do that. If that steel mill can make a profit, why don't I keep that profit? If the rubber plantation is making a profit, why don't I buy them and keep their profit?
Also, that way you don't have to worry about you can control the prices of your input material.
To a certain degree, yes. Yeah, I have never understood, why people don't do that. So when I was at Heidelberg Web Press, now Goss Printing in Dover, we had a big old machine shop, and we could do big parts. We could do just about anything in the shop. And at one point, we had extra capacity, and we were machining the Audi A5 flywheels for Audi cars. And I thought that was some really creative management. You know, at $200 an hour, keep that shop full and just cranking out parts. So,
I mean, for some companies, I'm sure it would be cheaper for McMaster Carr to make bolts than it would be for Ford to make bolts. Specialization of labor.
yeah,
But
and McMaster doesn't make bolts. McMaster is just a Walmart.
oh, okay.
They're just a reseller. But, you know, you're exactly right. You know, I forget who does make bolts anymore. They're all coming out of China now. But I will say there are some very good bolts coming out of China. You just got to pay for what you get. Okay, so anyway, this is what I was looking for the drawing on the assembly. So now let's go on. Let's do, what are we at? We're at 339. Let's do the shaft, the main shaft next. So let's see, we'll unexplode that. And we'll go to the main shaft. Make a drawing, piece part. Okay, this one, guys, was pretty much a setup for doing a broken view. I was really hoping you were going to see that you were going to remember the lecture where I said, if you got something long and skinny with small features, do a break and then bring the scale up so you can actually see what's going on. So we're going to say insert, drawing view, and break. I'm going to put one break there, one break over here.
Detail view would also work. But then your view of the cross end wouldn't be very big.
Let's reproject this. Okay, so center lines again. Always start off with the overall dimensions. We need a material note to know what to make this thing out of. So I'm going to go over to the main shaft. AISI 4340, the good stuff. Whoops.
It's really hard, right?
It can be very hard or it can be very tough. So hard is obvious. Tough means it takes a lot of force and yields a long distance before it breaks.
So it's used for shafts and axles, that kind of stuff.
So 4340 is used for aircraft frames. It's used for camshafts. It's used for gun barrels. Pretty much anywhere that you need a lot of strength, good corrosion resistance, and weldability. It's expensive, but it's really nice stuff.
Does that normalized mean that it's the tougher?
No, it means heat treated to a soft state.
So the hard, no, not the hard version then.
Correct. Yeah, if you have this stuff quenched and hardened, It is just, I've seen it be near diamond hard. It can get really hard.
Okay. I didn't know if the normalized was supposed to be on there or not, so I just wrote the whole thing, including that. But
That's all good. And
We learned that stuff, alloys, in a course, right?
yes, Professor Young is going to teach you all of that stuff in your materials course.
that's years away.
Oh, dude, trust me, it's closer than you think. Trust me, it feels like I was just sitting in those courses.
I think I got this course next semester, actually.
Yeah, you guys will like Professor Young. He's a good guy. Bit of an accent, but he's very conscious of it. So if you ever have trouble understanding or have any issue, you just tell him. He'll go over it as many times as you need. Yeah, real good guy. I like him. Okay, so we're going to start off on the ends. Now that we got the overalls, we're going to have a chamfer note on each end. So we'll go under smart dimensions. We'll get chamfer. Whoops. There we go. 31,000, 45 degrees. Same thing over here. And then the notch. So the way I would do this is I would call out the depth, the width, the distance from the end of the shaft, and you're done.
Those are exactly the same dimensions used for snap ring groove. Is that like a standard or something?
Pretty much. Okay, so unless I'm missing something, that's all you need. And you're done. Got to make sure the hidden lines are turned on. I want to see this little saw cut line. A bunch of people have been trying to detail the width of this saw cut. You don't need it. That turns out to be a double dimension. Just by cutting across at this depth automatically gives you this width. So you don't have to worry about that. Okay. That's all I wanted on the shaft print. And of course, fill in the title block. So let's see, we got to get rid of anything we don't use. We'll get rid of sheet 2. Make this sheet 1 of 1. Done. Okay, and the last thing we had to do was the bearing retaining cover. So we'll make a drawing of that. This one was also kind of a setup part because it has internal geometry that's hard to detail. I was really hoping you guys would put in a section view.
You couldn't you couldn't not put a section view, I think.
Well, what some people did, Emmanuel, was they looked at it and they said, I see a counterboard hole. And they tried to do it with a hole call out, which, you know, I can't really call it wrong, but it's not the preferred way I'd like to see it.
But where you put the notation?
So if you go,
Oh, from the bottom, if you see that from the bottom.
yeah, well, you can even put it right here. Hole call out. Oh, you're right. You got to go from the bottom.
So if it was a standard counterbore hole dimensions, it would be a good indicator to use counterbore.
Yeah, where this is something that holds a bearing inside of it, this is a kind of part you would cast and then clean up on a lathe. So it's not standard anything. In fact, in the real world, this would probably be a metric size hole down here. Even on the World War II Jeep that was almost all inch, the bearing housing is metric.
Why is that?
Because in the early days, all the best bearings were coming out of Germany.
Oh, I see.
So how do you convert the metric into inches, or how do you say when something is in inches, in metric?
So you can dual dimension it, and I can demonstrate that if you'd like. So a bunch of people did that, which, I can't tell you it's wrong because it's got all the information.
That's pretty good for something not done with Hole Wizard.
Yeah, it was pretty smart. But here's what I was really looking for. And, I will give full credit for that. I can't say it's wrong. But what I wanted was that.
Aren't there supposed to be hidden lines in section views?
No.
Oh,
And you can set it up so that they're either viewed or not viewed.
either's fine?
Yeah.
Okay, good. Because it didn't come in with hidden lines, but then I realized that they probably should be to show the other holes, and I'd rather have them than not.
Yeah. Typically in a section, you don't have them turned on, but there might be some rare situation where they'd be helpful for the understanding. So,
Okay. The hidden lines looked kind of weird to me, but I didn't dare leave them off.
so then I would do something like that. And go. So now we're going to need overall height. So again, we go back to the idea of how big a block of metal does the machinist need? So we've got that. And here's where I'm dinging a whole bunch of people, which is a little bit surprising. So a bunch of people have been trying to say something like this. And then they say, oops, this. So if you call out the bolt circle and one of these holes is right on the center line, you've got all of those holes nailed. That's everything you need. So this is kind of like a double dimension with this. So this needs to go away. This is absolutely non-standard. And then we'll put in a hole call out. And that's everything I need for that bolt pattern. Next, need the material note. So this was AISI 1020. Come on. And we'll clean up the title block. So this is all half scale. Sheet 1 of 1. Get rid of anything we don't use. Kept everything out from under the rev block. And let's see, have I missed anything? I think the only thing I might have missed is the width of this tower.
You want the outside diameter too.
Okay. And that's it. That's all it needed to be. I got all the information I need to go make this part now. And let's see. So my center line is going to be under this, so I'm not going to worry about that. And I should probably put some center lines here and here on these holes. And personally, I would hand that in and not worry about it. So just the big takeaway on this one was if there's anything internal, any kind of snazzy geometry, think about doing a section view. That was the big message.
Is there a rule that if you don't have a dimension that shouldn't be there? I mean, yeah, you have the section, the AA, but should you put the diameter on the bottom left view? So just you have a dimension, or doesn't matter?
I don't think it really matters. I mean, generally, if you've got a view that doesn't have any dimensions, you typically get rid of it. But I needed that view to create the section, so.
Okay.
I just put a few dimensions on there, like the width of the tower, and
You could, sure,
like
you
that.
could. Oops.
I had a question, but it's not about the exam.
Okay. Any question is fair game in office hours. Go for it.
So I was making it was like my last drawing it was of the double-sided tape, and it wouldn't let me dimension the hole.
Okay. Why don't I shut this down? You take the screen.
Okay.
And then I'm going to save all these so I can post them for you guys. Okay, Ethan, screen's yours.
So like, I have everything I need, and when I try to dimension, like even put like a call out on the hole, it won't. It says it cannot be converted into a line or circular arc.
Okay. Let's go into the model. Show me how you made the model. Because, yeah, those edges are not flat, but they are absolutely circular. Okay. So nice. Yeah, you did a 3/8 hole right through the center of that. Okay.
Yeah, but like it's like I don't know. This has never happened before when it just doesn't want to.
You're using the hole callout, right?
I mean, actually, I haven't tried that. But it just says please select the edge of a hole. And I mean, that's a hole.
Okay, so right click on it and try and do a select other. Can you put a center mark on it and dimension to the center mark?
No, it says the same thing.
Hmm. So let me give that a whirl because it seems like you should be able to do that.
Oh, one quick thing I noticed
Yeah,
you may
go
want
ahead.
to take care of. You dimensioned the radius of the well, let's see if I can pull this off. No, I can't. You dimensioned 2 radii in the view on the left, and then you give the thickness of the tape.
Good call.
And I guess it doesn't matter if you use this height on the right or an angle. I mean, either fully defines something, right?
Yeah.
Yeah.
Almost got it, guys.
I gotta head out. I have a physics lab, but you can email. I'll email you tomorrow, or you can email me if you figure it out.
Okay, I'm just about to do it. So
Okay.
when I brought it in, mine actually came in with the center mark on it. So I'm not sure what you got going on with yours. And all mine looks like, I mean, it looks like I did exactly the same thing you did.
Right. It's weird.
So my thought is I would just try redrawing it. And
Okay.
I did the extrude coming down. I put the whole wizard on this flat plane and projected it through the curved surface, and it picked it up
Okay.
just fine.
Okay. Thank you.
Yep, no problem, Ethan.
Okay.
This may be a question that's too involved to answer right now, but what if you wanted to cut a pattern into a curved surface? Can you put a sketch on a curved surface?
Yes, you can. Ooh. And that may be a question for Google, to be honest with you.
I see a command called warp, but I'm not sure what that is.
Oh, some of the folks have been twisting their rubber bands in their models.
Oh, that kind of thing. Okay.
Yeah. Let's see. Insert. Where's note? No, that's not what I want.
I mean, it's not something I need for anything at the moment, but
Well, to answer your question, yes, you can absolutely do it. So if I wanted to, I could put MEE 120 in curved constant depth letters right across that face.
okay.
And then I could go 3D print it or mill it or whatever I wanted to do. And I have done it. I do it like once every 3 years and then can never remember how to do it again.
What was the question?
How to put, like, if I wanted to put MEE 120 across this curved face in constant depth letters, how would you do that? And I've done it, but I just can't remember how to do it at the moment.
Because of the curve?
Oh, here we go. Text.
I put letters on my coin, on my bearing.
It's like how to put just any general sketch on a curved surface.
So this one is letting me do a flat surface, but it doesn't want to let me do a curved surface. So this was under tools, and it was sketch text. Yeah, honestly, I'd have to go back and do some Googling, but it
Okay.
absolutely can be done.
Okay, good. No.
I have a question after that about my my Sterling engine.
Okay, Larry, go for it.
You have to share my screen with you. I can't get the helix on the coil to mate with the rod. That's the issue.
Okay.
I don't know if you can see it or not, but if I click like mate on the helix here.
Right. So what I told you to do to take care of that is you put a hole right down the center of the helix,
Okay.
and that
then-
creates a cylindrical surface that can then be mated. Because you're right, those little spirally toroid surfaces, they don't mate to anything.
Right. Okay. And that nut that you designed in the beginning class, was that the one that goes on the balloon here?
No, it wasn't.
Okay.
I just randomly drew a 1/4-20 nut.
Okay.
By the way, I think you've told us this before. I can't remember. The The quarter means the outside diameter of the threads, and the 20 means 20 threads per inch, right?
Correct. Absolutely.
Yeah, I left that nut entirely off the drawing or assembly, partially because I didn't want to draw more parts than I had to, and partially it's more mass for the balloon to move.
But the thing about it is you're going to counterbalance that mass with the washer on the CD.
Oh yeah, right.
So it really doesn't matter.
Well, it still adds a few more pages that I'd rather not deal with.
Oh, come on. This is CAD class. This is fun. Didn't you get the email?
Actually, it would have been simpler to do it that way. Instead, I drew a crazy bent wire, which one page, but it's
Yeah,
crazy.
that's a lot of work documenting all those bends and locations. I mean, in my mind, that's more painful than just drawing a nut and a bolt.
Yeah, but I didn't realize that at the time, and now it's drawn, so I'll stick with it.
Okay, all good. All right, guys, any other burning questions? Otherwise, I have a little dog at home who's dying for some belly rubs.
That's about it.
And
Good.
I'm not cat related, but you may know the answer.
Uh-oh.
It's okay, quick. I have the choker cables on my skidder,
Okay.
and they are bent. Some of them are like that, you know, they have a permanent curve.
Sure.
Can I straighten them out somehow now that I have the acetylene? Can I, if I make them straight, can I make them stay straight? It's wire rope, 1/2 inch.
Honestly, I wouldn't try. Okay, wire rope is typically a 1095 high carbon steel. And if you heat it up to any extent, you're going to soften it dramatically.
Okay.
I just think you're going to run into a reliability hazard or some kind of problem.
Okay, I will just replace them then.
I would,
Okay.
yeah.
Okay, yeah, I didn't want to touch it before. It's weird stuff. I don't know them yet. Okay.
Yeah, I mean, it's nice. It's really strong and it works well in a lot of cases. But at the same time, it's not something you want to have break on you.
Yeah. Okay.
Okay,
Thank you.
Emmanuel.
Thank
Have
you.
a nice evening.
You too. Bye-bye.
Andrew, unless you have any other questions, I'm signing off. Actually, you have already signed off. So on that note, adieu.